In a lot of automated systems, you're going to see various automatic valves. You have solenoid valves, you'll have a pilot-operated valve, which you'll see on lawn sprinkler systems, and then you'll see motor-operated valves. The big advantage to motor-operated valves are it doesn't clog. Okay, the other types of valves will clog, but these won't. And the primary reason, okay, and assuming you can see this, all right, if you look inside, you'll see that shiny thing there, that's a stainless steel ball. In this particular position, it's closed. At 90 degrees to that, there actually is a hole drilled through it that is the same diameter as the inlet piping and the outlet piping. So when the valve opens, it's 100%. The second good reason you want to have a motor-operated valve, ball valve, is that if any little debris, other than like something hard which shouldn't get this far, but let's just say a piece of rock will, which can jam up a pilot-operated valve and even a solenoid valve because of the way the valve shape is, the ball itself has enough torque due to the speed of the motor to actually clip it off and cut it up and seal positively. When we put the system together, when we're sizing the valves, we always go for what they call a normally closed valve. That means that it only opens when the power is on. If the power is lost or the control system shuts it off, it'll actually self-close by a spring. It doesn't rely on power to close. It just relies on power to open. Another thing that you can do, okay, if you notice on this particular one, okay, is this little red line in this little bubble. Okay, that shows the position of the hole inside the ball. So in this particular case, it's across the pipe, which means there's no flow. We don't have this one hooked up to power. This one happens to be a 24 volt AC, which is a very common control voltage in the AC range for using these. We like this because of the with using the AC current, we can actually have longer distances rather than the DC current. Another thing that we always add, and this particular valve has, is this little gadget here, which if you lift it up, disengages the motor from the valve handle itself. So you can, and we'll go back to this, we can rotate this, and if you see in the little hole there, you'll see the ball turning. There it is. Here's coming into play. Okay, and now you can see the ball's fully rotated. It goes straight through, and in case you don't believe me, we can just do this, and you can see my hand on the other side. Right. Conversely, you can close it the same way. You'll also note on the little bullseye that the little red line is now pointing in the direction of flow, meaning the valve is open. It's a very handy feature. You don't have these on solenoid valves. You don't have them on the pilot-operated valves. So you could literally have a situation where you need to get water through to a system reservoir or other piece of apparatus requiring water, and you can manually override. Normally, you don't have to do any maintenance to these valves. As long as they're clean, they will work for years. We always install some type of particle filtration on the inlet to any of our water systems so that our water is clean. In primary case, we're using these to distribute oxygenated reverse osmosis water to all our reservoirs, our evaporative coolers, and two other items that we use that require clean water. The advantage of RO water in this case is there's no calcium in it, so you don't have to worry about things caking up. So that's motor operated valves. You take care of them, they'll take care of you, and thank you.